In this video, we're going to look at how you calculate the correlation. I'm going to use a data set called behavior that is also found in the SPSS package. So you see a whole series of behaviors: run, talk, kiss, write, eat, sleep, mumble, read, fight, belch, argue, jump, cry, laugh, and shout. These all appear to be on the continuous level, interval ratio variables, as opposed to categorical. So this is necessary in order to do a correlation. So correlation looks at the association between two continuous variables. And so this looks like a good data set to examine. I do not know what these scores stand for, but for the sake of this example, we will assume that a low score represents a lower interest in that behavior, and a higher score represents a greater interest in that behavior. So to calculate the correlation coefficient, we will go to Analyze, Correlate, Bivariate, which represents two variables. Correlation, since it looks at association, is less interested in what the researcher considers the independent and dependent variable, because it only looks at how those two are associated, whether they're strongly associated or not. So it allows you to just move into the variable box whatever variables you want to compare. It doesn't ask you to separate which one is the independent or which one is the dependent. It doesn't mean that you yourself can't consider that. But again, since correlation is only association, whether two variables hang out together, there is no independent variable or dependent variable. So let's say that we want to look at the relationship between people's preference towards kissing and eating. We go into options. It allows us to look at the means and standard deviations, which is always useful when wanting to describe the data. We'll hit continue and we'll hit OK. So there are 15 people total, and the value they attribute to the average kissing score was almost 4. The average eating score was a little bit closer to 3. And you see from the correlation of 0.829 that these two variables are highly correlated. If you recall from the lesson, a correlation ranges from either 0, which is no correlation or association at all, to +1, which is a perfect positive correlation, or -1, which is a perfect negative correlation. So in this case, it's a positive, which means that as a person's eating score increases, their kissing score increases as well. 0.829 suggests it's a very strong correlation. And if we take this value, which is the R, correlations get the Pearson's R. If you square this value, 0.829, you'll get 0.687, which represents 68.7%. This can be interpreted as approximately 69% of the variability in kissing is explained by the variability in eating. To visualize what this correlation of a positive 0.829 looks like, we can try graphing it. So if we go to Legacy Dialogues and do a scatter, and a simple scatter, we can move eating to the y-axis and kissing to the x-axis. Again, it doesn't matter which one we pick. Hit OK. And we can get that visualization. So this increase in this direction is what is due to it being a positive, or what makes it a positive correlation. And you could see that as the values of kissing increase, so too do the values of eating. So I also want to point out that you can see a mirror image here of the correlation, significance, and sample size. The reason for this is that the correlation between kissing and eating is the same correlation as the eating and kissing. This 1 represents the correlation between kissing and kissing, which means that they are perfectly correlated, that it's the same variable. And the same thing is true with eating and eating, that the association between those two will always be 1. It's the same variable. A particularly useful element of the correlation is what's called the correlation matrix. So if I go analyze, correlate, let's reset this. There are a lot of variables here, so I'm not going to use them all, but let's go from run to read, move them over. And so this is a matrix. By a matrix, it means that it has the same variables going across as it has going down. And so once again, like we saw when it was just 2 variables, right down the middle you see a 1, which separates the mirror images of the left side and the right side. So as this is the mirror image, we don't have to look at both sides, we can just focus on 1. And so what's nice about this is that you can really look at the relationship of many variables at the same time. Let's go across and look at run. So obviously it is perfectly correlated with itself. It has a moderate association with talking, a bit stronger association with kissing, again, a moderate association with writing, eating, sleeping, the lowest association with mumbling, and a moderate association with reading. So we could say that running and kissing are the strongest relationship, or the strongest relationship with running is with kissing. It's also important to look at the p-values, the significance that go along with this association, because that's the other part of the story when understanding how to interpret these. Again, with correlation, you would look at the direction of the relationship, the strength of the relationship, what the R square is, which it tells you how much of X is explained by Y, but also the p-value is always important, because if it is not statistically significant, it's telling you that you cannot apply whatever association that was found in the sample to the population. So in this situation, it is not statistically significant, these associations. So even though they're moderate, they're also not statistically significant. Eating approaches significance, but it doesn't quite make it. The association between running and kissing, however, are statistically significant. Significance doesn't necessarily come due to strength. It often comes due to strength, but it doesn't necessarily come due to strength. And that's correlation.